Hi Liam, how are you today?
Pretty good. How about yourself?
Yeah, I'm good. Before we start our mock interview, could you please briefly introduce yourself?
Yep, I'm Liam. I'm a mobile engineer. Have worked at companies like Coinbase and Digit, and more recently, I've been working on my own apps.
Yep, sounds good. Thank you for sharing that. So, today we're doing a mobile system design mock interview practice, and we need to design a simplified version of a Spotify app. So, we have three screens today. The first one, your library. Here you can see a list of different playlists or podcasts. For example, playlist with liked songs, some podcast, an album, or some other playlist. It should be scrollable. Next one is the playlist screen, where you can see an image for example, for an album cover. We should be able to see the list of songs in that album and play it. And the last one is the playback screen. So here, again, we should be able to see a big picture, album cover, and different buttons to play, go to the previous or the next song, or shuffle our playlist.
Okay, cool. Yeah, I think I have a few clarifying questions here based on this. So I'm noting that in the library, we need to support different types of collections here, which are like podcasts, which could have a bunch of episodes. A playlist could have a bunch of songs. I think that makes sense. The sorting is one thing I'm thinking through for recency. Is the recency there that I listen to a song, like that I listen to that collection, or is it when I liked created it or updated the collection?
Let's make it recency by listening.
Okay, okay, and then so if I listen to a song in the context of that playlist, but not necessarily, I guess for like songs, if I listen to a like song, that might bump the like songs to the top. But I could have a playlist if I had relaxing mix with like a song A and I didn't listen to it in the context of that mix. Does that make relaxing mix move to the top? That makes sense.
Yeah, that's a good point. So first of
I think
all,
probably not, right? Because it's not in the context of the mix.
one song can be in two playlists, and
Right.
what happens in this case? Anyway, I think we can assume that this sorting logic is on the backend. So
Okay.
yeah, we can just use recent sorting, or for example, by date added.
Okay. And then are there other sort types then, or it's just kind of date added? It's not something that can be changed.
Just date added and recently listened, two different sort types.
Okay. And then let's see here. In terms of listening, I think, do we want to have offline support for this? Is that a feature that we want?
Yeah.
Okay. And then, is there any video support for this?
No, let's leave video out of scope for today.
Okay. And I think I can start to sketch out the functional requirements. I may have some more clarifications as I go here, but let's just get rolling on kind of listing these out. And I'm going to go kind of left to right in terms of the screen. So we want the user to be able to view. Okay, so a user can view their library, and in this library context can be sorted by recent or last listened, last listened. And then they could tap on one of those playlists or podcasts and go into a details screen. So user can view details. And I'm going to call these collections a collection. So that handles things like albums or a podcast, which has a collection of episodes, or a
Okay, got
playlist.
it.
And this has additional details in this screen, like the track list. And then on the screen, user can play a collection. I'm guessing, can they also play, when they hit play, it might start from the beginning, but they can also tap a single song, which would play in the context of the, maybe start from wherever that song is in the collection list.
Yep, sounds good.
Start or any index. And then on the playback screen itself, user can control playback. There's, play, previous, shuffle, next. And
Mhm.
then I think those are kind of what I'm seeing for the main functional requirements. In terms of non-functional, I would consider like offline support part of this, so that the user could keep playing or play songs that they save. I think that does raise a good point in terms of what falls into saving here. Is there an explicit save button, which I don't see, or is there some kind of just caching that we do of recent songs?
Yeah, that's a good point. We don't have it in the mockup. Let's actually assume we have this button somewhere, just a save locally button.
Okay. So we'll have some kind of explicit button to save. And then additionally, we want to support streaming, and that can be in like low network conditions. And so, yeah, we'll low network support. So we'll want to handle something to allow for some kind of adaptive streaming there. And then anything else for non-functional here? Oh, I guess in terms of scale, I think that's one thing I should bring up because it probably impacts the design of this somewhat.
Yeah.
Is there a certain scale of users we're targeting here?
Yeah, let's assume we need to support 100 million daily active users. So it's a high scale application.
Okay. So those are the main functional and non-functional requirements that I see here. How do those look to you?
Yeah, that seems reasonable. Also, I think I want to add one thing. We need a seek functionality. So basically, when you're listening to a song, you should be able to change the timestamp, like to seek to a certain place.
Okay, so I'll say including seek. So that could be scrobbling, I think it's called, like on the time area. Okay.
Yep.
That makes sense. Okay, so now I will jump into the API design and data models. So what I'll do is get the API endpoints up first. I think overall, I think we can assume that these are authenticated endpoints and we have authentication set up. And so I won't touch on that portion, but I'll structure these as JSON endpoints and using REST APIs. So for the library, an endpoint like /me/library, which just signifies that this is accessing a resource of mine. And we'll want to have the sort order as a parameter here, and some kind of pagination, so an optional cursor in case this library is very long. And then we could have a limit as well, so that the client could specify.
Why do you want to go with cursor-based pagination versus offset-based, or some other way to paginate?
Yeah, it's a good question. So if it was offset and we changed the ordering of this, so if like the user kind of liked songs on their desktop, if we then came back to mobile and they were offsetting, it wouldn't have that latest update when we would want to use cursor based to reset that context.
Okay, so because our library can be dynamic in a way.
Yeah.
Another question here, sorry for interrupting. So I can see that you included sort as one of the parameters. So some people prefer to sort on the client. So how to choose between sorting on the client or including that as a parameter in the API?
Yeah, I think we would want to have some kind of optional or ability to sort on the client, but in terms of including it in the API, if we have a very long list and we just sort purely on the client, that's only going to give us what the client can see. And so if we were to sort based on, something like last listened at, and last listened at has changed recently on the back end, or basically for the long list, we need to be able to sort and like see the full context of the list. I was struggling to come up with an exact example there, but I think for the recent, if we sort by like recently added and were to sort like us from like the reverse direction, that would be an example of when that wouldn't be supported by the client because it wouldn't have the full list of the library, so it
Yeah.
wouldn't be able to do that reverse sort.
Yeah, good point. I would add pagination on top of that. If we're paginating an endpoint and sorting locally, it could break things.
Yep. Yeah. Okay. So for here, what does this endpoint return? It will return a list of all these like library items. And I'll define this in a second. And then a cursor as well, or a next cursor, so that we can continue paginating. I will define some of these data models in line as I go here, just so it's a little clear what they look like. But this library item will have an ID. Let's see here. And then what else? What I want to do here is have some kind of common collection summary object. So that's going to speak to some of the details of the collection. And the reason why I'm kind of abstracting it out to its own thing is that I'll be reusing it for composing the kind of full collection aspect. And so on this library screen, we don't want to include all of these tracks that are in a collection, because a playlist could have, thousands of songs. And if we have a bunch of playlists on the library screen and we load all those songs, that would take a lot of data to transfer. And so we'll have this collection summary, which just has the overview of the collection, a title, item count, so we can say the count, a type, which would be like a playlist, album, or podcast. There might be another type here. And so
what if we can have different fields based on a type? So for example, for album, we need album cover and album name, but for podcast, maybe, we need something else, some additional metadata.
Yeah, we can definitely support that. I think the question would be, would we need that on the collection summary? Because from what I see here, like we could structure the collection summary that way. I'm kind of thinking that the collection, there's going to be a collection detail as well that could handle this kind of more custom metadata. But because from where I see it, we could do like artwork URL here, and this could be actually like an array, because sometimes Spotify blends together some, but we could just call it URL. In terms of these, reasonable. But either way, wherever we need that different level of data, what we can do is have an enum in Swift, and it has associated values, so that if we wanted to have customization on the collection summary, we can have that as a stored, custom object here, which I'll do in the collection detail, because there are differences in the detail screen between a podcast and a playlist.
Yeah, it makes sense. Oh, yeah, I agree. It's better to do this in the detail screen, not here in the summary. Yeah.
Okay. So what else do we have on library item is, I guess, if we're supporting recency, so the backend could provide a sort order for when, recency, we actually don't need the sort order unless we would have some kind of custom sort besides recency. So it's like recency would be like updated at, I think, and then last listen at, if we wanted to do also support last listen. And that last listen at is going to be something that will do some kind of optimistic write to locally for the client if we want to have the client handle offline support of like listening to a library, a playlist, and having it bump to the top. But we can explain that
interesting.
later.
Yeah, we can do that. If we have time, we can support it.
Okay, so yeah, let's try to get through some of these other endpoints. So we'll have /collection/ID And again, here we do need pagination because we could have a very long playlist or podcast list, I guess. And this is going to return our collection summary, collection detail, and then not tracks, but like items. So for an album, this could be tracks, but our items is kind of like a new data type we want to support, which is like a generic type to represent a track or a podcast episode. And I can show what that looks like in a moment, but I just want to make sure that this makes sense. So the idea here is that as we paginate, this collection summary and collection data will remain the same. The items that we return will change because we'll be going further down the list. So the collection detail has all the information that is additional on this detail screen. So I'm trying to think what else we would need here, but things like album notes, description. There's a lot of potential other metadata that this screen has. I think for the most part, a lot of the stuff we see right now is in the collection summary. Then I'll call we'll have this array of what I'll call playable items. And this is where we'll want to have either a track or an episode, right?
Okay.
And so this kind of speaks to what you were asking about before, if things are a bit different. We'll also handle the playback of these a bit different because a track, we always want to start from the beginning. An episode, we want to leave where we left off. And this might be, yeah. The episode, I think, makes sense for now. I think they added books. That's like something similar to an episode, so we might come up with a better name, but we're not supporting books for here.
Yeah, let's leave books out of scope.
So yeah, as we paginate, our list of items here is a list of, I'll just say, playable item. Okay, and then we have our collections /ID. I think if we have an item /ID, this would be our playback screen. If we're navigating straight from this collection detail screen, we may have most of the information here, but we generally want to have an endpoint to do this because we might deep link in here. And so we'll need to have that full context of the item.
Got it.
And then additionally, this is where we need to kind of discuss the streaming, I think. So for a given item, we might call this like stream info. We need to return how we stream this. Okay, so up to now, we've talked about the metadata. And so I think here, it would make sense to just quickly touch on what the streaming setup looks like. And so for these type of apps where we want to support some kind of streaming, there's existing ways of doing this. On Apple, HLS is developed by Apple and generally makes a lot of sense to use for this type of use case. There's also Dash, which is open source, I think, and is supported on Android and cross-platform. So the general idea is that we want adaptive bitrate streaming, which will so the client will be able to dictate, what quality based on the network conditions and maybe battery. And then also we can do that I guess maybe that's implied by streaming, but we want to be able to do chunk downloads of this. And so that's what HLS will allow us to do. Our backend could maybe support HLS and Dash, but on Apple, we'll just go with HLS. There's some nice built-in things that Apple has to help support it, including offline support.
Okay, got it. Quick question here. So we have a non-functional requirement, low network support. So how can we solve it? How does HLS help with low network support?
Yeah, I think in terms of the chunk downloads and also having different stream qualities that that the client can choose from, so it can degrade from the most I don't know the exact bit rates for music, but like the equivalent of like 1080p for video down to like a lower bit rate as the network conditions degrade, or maybe as battery gets low. And so
Yeah, yeah,
that
makes sense.
allows, and so that's kind of what this protocol helps allow for.
Yeah, so basically we're just lowering bitrate when we have limited network.
Yep.
Yeah, sounds good.
Okay, so we'll just have it like, we'll have this support HLS primarily, but we'll just have this endpoint set up to say that includes the type. And then I think we want to have like a manifest URL. And there might be an expires at too. So because that's one of the complications with some media systems like this, is that if there's these, we wouldn't want these URLs to live on forever, because we would want this to be generated from an auth endpoint and then some kind of URL that returns to the client that is only valid for a certain period.
Sorry, what is manifest URL?
That gives that, so HLS has an idea of a manifest, which has the download broken into chunks and also the different bit rates. And so this URL is essentially tells us for a given item, like a track, how do we go about taking that track and then streaming it.
Got it. Yeah.
So in this, like HLS here, I would just say that this is probably behind some kind of CDN or something like that, so that when we actually request the get manifest, that returns, I think this would be like, high quality with a list of URLs. And so this is like broken up into, I think, like 2 to 10-second chunks. And so a given song will have a number of URLs here, and then medium, etc. And then we'll have there'll be like an endpoint for item / that breaks this into individual like chunk ID. So this is quality, and this is all appended to that whatever dynamic URL is returned there.
Sorry, could you repeat please the second part? So the first part, we get the manifest file that contains arrays of URLs for different quality types. So why do we need a second part?
This is kind of just defining what each URL looks like. So each individual URL is then going to point to some endpoint here. And these URLs are like basically composed of some kind of quality and chunk ID, because it's like,
got it.
Yeah. That's my understanding of it. It's something like this, if it's not exactly this, where like we get a list of the URLs per quality, and then each of those URLs is representing whatever quality they're at, and then we can download from each individual chunk ID.
Yeah, sounds good.
Okay, so when we have, I think we want to call this something like the actual asset here. I can define like the track and the episode are also things that we need to consider, but I'll just maybe leave them right here for now. Those have things like title, artist. Playable asset, this is this has the item ID and then the actual stream info. It could just be the stream URL, I guess the stream info, which includes manifest URL and expires at. And then, so that's how we like fetch. And so this is linked to an individual item. And then, yeah, I mean, it might make sense to touch on here just the overall like model type for how we listen to the music too, like the playback state.
Yeah, let's talk about it.
Okay, So we'll have, there's like a few different, I guess we can call this state, and this is something like idle, playing, paused, seeking. And so this controls what the user sees on screen, and then the user, as they kind of interact with the screen, it's changed based on that. And then we'll have the actual playable asset here, the current playable asset, and then something like a queue, so that we're able to determine what's next. I think we haven't really discussed prefetching stuff, but we would begin to tie in prefetching in this queue here. But I don't think we need to discuss that currently. But this queue, I guess, is what, if you start from the first track of Nevermind, it would be filled up with the rest of the tracks, which I can show in the high-level design.
Yeah, I think it would make sense to discuss this as part of the high-level design, looking at schema.
Yeah, that makes sense. Yeah, so I could jump into the high-level design if that makes sense.
Yeah, let's do that.
Okay. Just trying to zoom out here. Okay, and then I'll structure this as 3 different layers up here, like a presentation layer, business logic, and then a data layer. At a high level, say that we're using dependency injection protocol based to make things easier to test, and what that means, and like a view model based approach. And so overall, what I'm thinking here is that each view has an associated view model, and the view model has dependencies related to the functionality of that screen and whatever underlying data layer there might be. And that allows us to swap out implementations and test things without having to load up the whole view, and we can test independently of that whole SwiftUI or UIKit view. In terms of SwiftUI and UIKit, I'll start focused on SwiftUI. If there's any kind of performance considerations, that's when I might dive into UIKit. But these days, out of the box, SwiftUI can tackle things pretty well. So
yeah, sounds good.
Okay, so for a given screen, like the library view, that'll have a view model. And then here, library repo. So our repository is going to abstract out the access to our API client and our local database, which allows something like the view model to not have to care about where the data is coming from. It just knows that it can request data from the repository. So our local database I like to point out that it's our single source of truth here, meaning that we can observe changes to this database, and as we receive updates, as we fetch updates from the remote API, store them in the database and use that to update the view model downstream. And in terms of database, technology here, I think SQLite is good to use out of the box. It's like well supported, well understood. Our models are relational models here, and so using a relational database like that, I think, makes sense.
Would you use any frameworks like Core Data, Swift Data, or just pure SQLite?
I would use a framework. GRDB is a framework I like to use. Basically, I can include that here.
Yeah, let's include that.
It's an open source framework that allows for, one thing that's really nice about it is that it allows for observing a query and providing a async stream of a given query. And that really ties home this idea of a single source of truth, so that we can say, okay, observe my library query, and then as I update the database from any remote API calls, that async stream flows downwards to the view model, which is the view model is observing that stream. And so that means that it really ties home the idea of a single source of truth. And so that's one reason why I like it.
I have a question here. Would you work directly with GRDB framework from your repo? Don't you think it would be available to abstract away from the framework, maybe add something, some entity in front of local database? Or
Yep.
do you think that's redundant?
No, I think that's a
How
good
to choose?
call. So yeah, having some kind of abstraction around there, maybe like a store. So, and I think it's actually a good point here because I can show where that might come up. Is like if we have a library store which interacts with the database, and yeah, it's nice because our repo then doesn't depend on GRDB, but additionally, we can break things up into stores like this. And as I was pointing out with like, we have this embedded collection in our library API response. And so I'll just kind of draw these arrows here. Okay, so these stores allow us to access the underlying database and kind of abstract away this GRDB layer as well. And I think it's important to point out here that we want to use something like a collection store because as we update collection summaries from this library endpoint, we want to share that underlying data with any other screens that might access it or any other points in the app, like the collection detail screen. And so these help do that as well.
Sounds good. Yeah.
Let's just get to the back end. Just a quick sketch here. We can say that this is an API gateway. And then this can be pointed to our API servers. Okay, so yeah, our overall data flow here for the library view is wired up. I think at this level, we can also have a navigator just to show that when we tap on something in the library view, we'll then go to the collection detail view. And there's a similar level of flow here, a view model. And then our repo here, I think we can just call this a collection repo. I might actually call it a playable collection repo just because collection is kind of like, a generic term on Swift. But this collection repo will go into this collection. I guess we can point to this collection store to access the database. And then also there'll be playable item store. And so this is where we store individual tracks, the metadata about individual tracks. And then we'll have a playback player view. And this is a player view model. And then a service, which is going to, I introduce services when there's kind of multiple underlying repositories or a few different things going on. And so this service is going to, it's going to manage this is essentially going to be talking to AV player, but to abstract that, we can call it like a player engine just to have the overall shape of this and then point to this, which is essentially like an external dependency of AV player. Okay, and then our player service will touch a few of these existing stores. And what else does it need to do? Just change this color. We'll also look at the player service needs to call into something to fetch a given URL for an asset. And so this is a playback asset resolver. So what this is going to do is search our local download store.
Okay.
Which is where we have metadata about anything we've downloaded, and then also hit, this could be like, this is going to be, I guess there would be, we want another layer here for our media API client.
Okay.
Okay, which goes to this CDN, HLS, CDN. And let me just see here. I think I need to discuss our player service. When we land on the player view, right, we'll have an item that we want. And so we'll fetch it from our playable item store. That item, we then need to map to an asset. And so this playback asset resolver, our player service, I think this playable item store, we need to...
Yeah, could you, sorry for interrupting, could you please explain why do we need playback asset resolver? So what does it resolve?
Yeah, what it resolves is we're going to pass in here a given asset, and we need to know, do we have this locally or do we need to fetch it from the remote? And so what that's going to, it's going to resolve and return a file URL, which could be a remote URL or a local URL. And it uses a download store that this is a local database table that we write to when the user taps download. But yeah, the resolver essentially resolves, do we have this file locally? If not, I'll fetch from the remote API, the media API client.
Yeah, by the way, where do you want to store like files, audio files, in the same GRDB database or somewhere else, like file manager?
Yeah, so we could say local file store. This, we're going to have it's kind of getting crowded on here, but I'll just say that this is like a download service that handles the actual downloading. I think in terms of how so this download service downloads to our local data store, and if a user taps save, it would save that file. The flow from downloading an HLS file, I'm not entirely sure of, but I think basically we need to ask a special version of URL session to download it. And it is not necessarily in a file store that we can access, but I think that this kind of points to the right thing. It's still a local file store on disk that I believe is managed by the AV Foundation library or whatever audio-visual library on iOS. And so it's essentially an on-disk file store. We have I think less management of it, but we could probably evict things as the size increases. And so we would want some kind of LRU cache here and maybe a user configurable max size with a default at maybe 250 megabytes.
Yeah, we should be careful here because if a user clicked download, offline download button, we don't want to lose that song or playlist. What do you think?
You mean in terms of the size?
Yeah, in terms of the size. So we don't want to blindly delete
that's true.
something that was cached previously. So yeah, I think it's better to give user the ability to control it.
Yeah, I think that makes sense. I think the question is what's a smart default, because there needs to be a default. And so potentially we can calculate this based on how much size they have available, maybe and then, say the default's something like 1 gigabyte. But yeah, there is some kind of setting in there that the user could override. I think that makes sense. And then our policy for what we evict would be our LRU, least recently used policy. Let me see.
Yeah, sounds good. What about do we want to cache currently played songs on disk or not? Or because I just realized we have two types of cache. The first type is that when we manually explicitly decided to download a certain song, and second type is just the songs that recently played.
Yes. Yeah. I think there we would also want to do some kind of store caching and maybe a different version of this file store, like using a similar same idea, but just that is like, a smaller max size, something like 100 megabytes, maybe 200. And this could also be user configurable.
Yeah.
For now, I can just say it's part of the download service, because we might want to call this something else, like a cache like a song cache service, or excuse me, a playable item cache service. But the general idea is that, and this is just like a really traditional, least recently used cache, we just store whatever was recently listened to.
Yep, makes sense.
Yeah, and I think one thing to point out with this player service, which I don't think it came up in the functional requirements, but is a good question at this point, is like, okay, in terms of a background playback, not sure if we want to support that, but that's one thing we would want to consider here. We would need to like register for background audio modes, and then also have like a single instance of this service. Just if we think about the dependency injection graph here, like this is going to live, if we hit play on the details screen, we generally want to keep the track playing regardless of what screen we're on. And usually there's like a nice little indicator at the bottom of the screen to show you the current playlist or what's currently playing. So I think that this player service would kind of live on in the overall app and potentially not strictly this view model. That also is one thing that this player service would need also here. You can just kind of put it in here as like a queue, which I mentioned in the playback state, but this queue could start out being an in-memory queue, and then also we would want to persist it to the disk.
Why do we need this queue?
If we want to return and keep playing when the user closes the app. So usually, like if a user hits play and then re-enters, we want to know the state of things when they re-enter so they keep playing.
Yeah, but even without that, let's say you clicked play on a certain album. That means that you need to play song after song. So where would that information be saved? Basically, the next song that you need to play.
Yeah, it would be stored in the through the player, like in the queue, which the player service owns. And so this player service is essentially, the player view model holds onto the player service. But the nice thing about this is that we could, if we had it, we actually might want to have this player service at a higher level so that that queue is like accessible across the app, and that this playback service is always kind of available, which I think is probably what I'm starting to lean towards now, because right now this is, this player service works in the context of the player view model. If we just kind of moved it out to the top level of the app, then it could always hold on to that queue.
Yeah, what if we can click play button from the collection detail view model from a detail screen?
Yeah, the current way that works is that it would push on the player view and start playing, and so there would be like a deep link kind of into that player view, which would have start at this song with this additional playlist, or like with these additional tracks. I think it could, if we move this player service, which I think for a general music app we would probably want to do, to like a top level, then we could have the player service accessible by this collection detail view model, and we wouldn't necessarily need to make that transition into the detail, which I think is kind of maybe more in line with the spirit of the mock-up. Now that I mention it, is like we want to be able to access this player service from this view model. So like right now we could kind of add this dependency here, and we don't need to make that transition that I was saying, because I was thinking of this as like a linear flow for simplicity, but we can just kick off the play from the detail screen and not make the transition. But the important thing too there is that this player service then is, it's the same instance when we go to the player view.
Okay, got it. Yeah, I think both approaches are fine. So I think, could you please do the data flow? Let's say just what happens when the user opens the app. It sees library view. So what happens after that?
Yep. Yeah. So when the user opens the app, they'll see the library view. It'll kick off a task from the library view model. And the library view model exposes some state, which is the list of library items. And so
How would you implement it in Swift? Is it like add observable or add observed object?
yeah, so if we're targeting the latest iOS, or I think iOS 17 and beyond, we want to use add observable and expose some state here, which allows the view to update when that state changes. We can also expose like a loading state, and so when the library view model receives that call to fetch initial data, it calls into the library repo with a start observing, and the library repo exposes an async stream that the library view model can observe. And then as part of that start observing, it also kicks off an initial fetch to the local data store. And it just starts observing the local data store, which triggers a fetch of whatever's in there and pipes that back through that async stream to the view model, which then updates the view if there's anything in the local database. It also does a fetch of the API client to fetch the library endpoint.
Wait, so how does it decide what to do? So let's say you had something in your cache, in your database. Can you show it right away on screen, or do you want to wait for the request to finish?
Yeah, it shows right away. So that basically that kickoff of the database query will populate the stream with whatever's in the local database, and so that'll show right away. Additionally, on this view model, we'll still be showing the loading spinner, so we can kind of have like a loading spinner that doesn't block the main list, that just to show to the user that this is not the latest data. And so that keeps spinning, and then as the API client returns, it saves the data into the database, and that pipes any data that's saved to the database is piped back upwards to the view model.
Sorry, let's take a step back. So you get a JSON file from the API. How would you parse it? And where would you do it? In the API client? In the repo?
Yeah, so we'll parse it. We'll have like data transfer objects that are codable. And so those will use like a JSON encoder or decoder to decode the API response. Where would we do that? In this somewhere between the repo and the API client. So I think like we'll have like a utility layer between the two that can take our API models and map them to our domain models. And so that kind of maps from whatever is returned from the API to our domain models.
Wait, let's make it more concrete. So what sort of utility layer? Do you want to add an additional component here for parsing or not?
Let me think. I guess so. I might include, I might make the API client have like a helper method that takes in, a codable model that it can kind of map to. Yeah.
Okay.
Yeah. Does that make sense?
So it depends on how big would be our parsing code. So with codable, it's usually it's not that difficult. It's just a few lines of code. So I'm thinking like, do we really need an additional component here, or can we just do it in the client or in the repo for simplicity?
Yeah. I think that makes sense to me. Yeah. So then we decode that data and store it in our local store, which then updates the stream and flows back through the view model. Then the view renders the data from the view model, and if the user scrolls, there is an additional method in the view model to say fetch more items, and that's where we pass in a cursor, and we could store that cursor in the library repo and just have a single method that's exposed that says like fetch more items, and it could be based on the sort of the, like we pass in like the sort parameter, but the repo could hold on to that pagination info
Interesting. So you want to add state to the repo in the form of a cursor.
Mm-hmm.
Do you want to store the same cursor in the database or not?
No, no. So just it's kind of like a short-lived. So as long as this app is open, we'll kind of consider it being like a session of the user scrolling, and then we'll kick off a new fetch when the user reopens the app.
Oh, makes sense. Yeah. So we consider just ephemeral data that we don't need if the app
Yeah.
dies or the user just closes the app. We don't need it on reopen. Yeah, it makes sense.
Yeah. So that would be how the library view. I think that's the main functionality of the library view. I guess we could talk about how if someone's like listening, if someone's we haven't talked about how like the library view could be resorted or how the items in there could pop to the top of it if I listen to a
Oh,
song, right?
yeah, yeah. Let's discuss it.
Yeah. So on this library item, we want to be able to update the last listen at when a user listens to it. So as part of our playback in our player service, when we listen to a song, we're going to want to know the context of the collection that it was in. And let me see here. The library item, I'm just trying to think if the library item, right now I have the library item has last listened at, and I wonder if the collection should be last listened at instead of the library item, which I think might make sense to move, because essentially we want to update the last listened at somewhere so that this sort can then update. And
Yeah.
the library item, I don't think is the main thing that we want to have the last listened at. I think we want that on the actual collection itself. We could actually move it to, I think the real way to do this would be to have a separate table that's like user or like, yeah, collection interactions or something like that to manage like the state of someone maybe liking a collection and someone like, did someone last listen to it? But for now, I think if we move last listened at to the collection summary, and then that is when a user listens to a song, we look up the collection that it's part of and update this last listened at.
What if one song is part of multiple collections? Would you update? I guess it makes sense to update all of them, and then
I think what we need to do is retain the context of the collection in the player service. So because I think if you have I don't know, let's call it like happy playlist and sad playlist, and for whatever reason one song's on both, but you listen to the song, I think it should only move, and it's on the happy playlist, it should only move the happy playlist, I think, up to the top.
Oh, true. Okay, yeah. In this case, we are just updating one collection.
Yeah. But I don't know. In the case of a podcast, it might be different, maybe. I don't know, because like, I don't know if you can have a collection of podcast episodes that's not a podcast, but so if you had like a playlist that's a list of podcast episodes,
okay,
would that then update that playlist and the podcast that it is to the top? I don't know.
Honestly,
I guess we could keep it
need to
simple.
follow. No, I think we need to follow similar approach with podcasts. Yeah, just update one playlist.
Yeah. So then in that sense, I think it makes sense to have it on this collection summary. And so when we listen to a player service, like it has the context that it's added from. So the playback, I guess, asset or the playback item would need to have a reference to the collection that it's a part of, or we would pass that into the player service. It's a little tricky for me to see exactly how that looks right now, but essentially we need to update this collection last listened at.
Okay, got it. Yeah. Let's talk once again about the data flow for the player view and what's happening here. So we defined main components and their responsibilities, but let's discuss again like how it would flow just from start to finish.
Yep. So yeah, the player view is we would pass in a player view model with a reference to a playable item, which is we just call it the track here, and well, I guess we would pass in the player service to the player view model, so we would kind of not pass in an individual track to the player view model, but pass that into the player service along with whatever queue is associated, like the next items as well. That then kicks off a fetch to, we need to be able to translate that item to an asset. And so we get the item from the playable item store. I think we might actually need like a playable items repo here, because we essentially need to fetch. It's a little tricky here, but essentially we need to fetch it from remote or local. Playable item repo, right? This playable item repo gets like the metadata about it, and then we need to translate that item into an actual asset. And so that could be done in the player service. We actually might want another thing here, or we could do it in the playback asset resolver. But the idea is that we need to get an item, translate it to an asset, and then pass that asset into this playback asset resolver, which gives us whether we have the local file or fetch the remote file.
Just to clarify, so the playable item is just a song or an episode of a podcast, but when we click play, we actually need a manifest file with URLs. So that would be playback asset. That contains URLs that we can use to actually play song using adaptive bitrate streaming.
Yeah. And the tricky part there is like, we could ideally, in an ideal world, I think we would just maybe store that on the playable item, but because those URLs are kind of like can be changed right there, they're like short-lived URLs. So because of authentication, so like we can't just like Spotify can't just say here's the URL to play Smells Like Teen Spirit, because then everyone can just access that. So these things, that's why we need to kind of have this concept of a playable asset, which maps an ID to the stream info. So where does that live? We potentially might need another repo, but we could also say that that's part of the playback asset resolver that takes in, we could just say that the playback asset resolver takes in a playable item, which would make it a bit simpler for the concept of this drawing, fetches that stream info from our API client, and then looks for that manifest URL. Do we have this item in our download store? If so, return that. And then if not, return the remote API and return the remote URL and store that remote URL, send that back to our player service. That then is passed to our player engine. So our player engine can play a remote URL or a local file URL. So the file the item that's going in here is a playable asset with the stream info, which is then passed into AV player. So I think the core thing for AV player is it needs that URL. So we have like an AV asset URL that is constructed from that stream info. So then that starts playing. We have this state in our player view model, which is the playback state. And so we need to coordinate that with the AV player. And so that state maps to the underlying AV player state. And so I don't know exactly how AV player exposes its state, but essentially like when we hit play in the player view model, that tells the player service to play, which passes down to the AV player to play. And then I think there's some kind of maybe callback or state that would be exposed from AV player to link the status of the playback to our like view model. And then that's where we render the controls in the player view.
Okay.
And then
Yeah.
things like scrobbling would be a view control that plugs into the view model, and our view would translate the position along, we can call this like an x-axis, right, to how long the song is, and then tell the AV player to seek, to that position. So if you're 50% of the way through a 2-minute song, we say seek to 1 minute in to the AV player. That so I think the AV player too, I'm pretty sure because it's like optimized for HLS here, it would then do some level of the prefetch or like the fetching around there. That's kind of one of the niceties, is that it works with these. We can, as long as we get that URL to there, it can handle the
Okay.
fetching and adaptive streaming.
Yeah.
That's one thing I would want to look into a bit more here, because it seems like a bit like we're really just handing off some of these core aspects around like how the bitrate, for instance, adapts to the remote connection, to our internet connection. But I actually think, that's part of the power, I think, of using like an HLS type thing, is that Apple says, okay, this is how you do it. We've kind of they have a bit more expertise at scale. Potentially at Spotify's scale, you begin to then have different perspectives on how these things work. But for an initial implementation, it should be pretty good to use like the HLS standard.
Yep. Yeah, absolutely. All right. I think we're good here. I want to do just this one small deep dive into testing. So let's imagine, if you were writing a testing strategy for this system, what sort of tests would you include? Unit tests, integration tests, UI tests. Could you walk me through what do you think makes sense here?
Yeah, I think all of the above. And so, we kind of want to be looking at unit tests for each component in isolation, and then integration test to see how these things connect. And so that's where really this dependency injection comes into play, so that we can plug in, for instance, a mocked network API client and maybe a in-memory file store, and see, when we try to call the player service play, does it call into our components as expected without having to actually make API calls against our remote server? The unit testing would allow us more granular testing for how each individual component works. For UI testing, I think full-on flows, some level of UI testing would be good here. And then I think when, in my experience working with music and like hardware related stuff with Apple, some kind of manual testing layer I think is actually needed, because how do you say, if you are making changes to the core player functionality, having some way of testing that kind of still works. You can only get so far in a simulator for something that's integrated with the hardware like that. So I think the integration testing should cover a large amount of what you need there, and like hand off up to the point of the AV player, but having some kind of visibility into actually how the whole system works, whether that's with the QA team or like just internal team testing as well.
Yeah, makes sense. What sort of test coverage do you think makes sense for unit tests and for UI tests? Give me a percentage. What
Oh,
do you think would be a good
I don't have a
number?
percentage. Yeah, pretty high for unit testing. For UI testing, I think, core flow is a good amount. So I don't have an exact number. It should be, majority for unit testing and like integration testing.
Yeah,
For
makes
UI
sense.
testing, it's a little tricky, because the more you add, if you have zero flakiness, then I would say, do all of the UI testing, also have a very high standard. But it can be, it depends on like how the setup works, and how much time you have in terms of like a platform team or to debug UI tests. So I would kind of emphasize those least and really rely on the integration and unit testing
Yeah.
to handle that.
Yeah, I agree. I would probably go with higher test coverage for unit tests and definitely lower with UI tests because of flackiness and other problems. All right, let's wrap up. Thank you for doing the mock interview. Give me a minute to write up my feedback for you, Okay. All right. So let's take a look at the feedback. Do you see it?
Yep.
Yeah. So again, thank you for doing the mock interview. My decision is higher for senior engineer. Let's break it down. So for problem navigation, you were driving the discussion. That was good. You asked reasonable questions and wrote requirements, functional, non-functional. You identified and focused on main problems. So here they were the playback feature and the offline support. Okay, you had good organization of the problem space and good timing for a 60-minute interview. So I want to clarify that some interviews are 45 minutes, others are 60, and you have a slightly different pace for different interviews. So for solution design, you did well with REST API. Also, you explained adaptive streaming with HLS really well. Then you moved to high-level design. I liked how you explained your architectural principles before jumping into the diagram. That was good. What can be improved? Maybe be a little bit more proactive with adding store or storage on top of a database. What you did well, you mentioned an interesting detail about download URLs, that they include some metadata that can be changed because of the authentication on Spotify servers. That's an interesting detail. Yeah, we didn't have time to go deeper, so for those who is interested, you can Google this topic. Okay, another thing that can be improved is, yeah, I would say going through a full data flow in the end is really important when you finish the diagram, because sometimes you can uncover certain things like missing repositories. Yeah. Other than that, you handle scalability, designed with UX in mind. And for technical proficiency, I liked how you explained all the details as Swift UI, used observable, async streams, modern APIs. That was good. And technical communication was great as well.
Awesome.
All right. Yeah. Thanks. Thank you for doing this.
Yeah. Thank you as well.